Exercise 10.2 is asking you to draw a molecule when you're given its name. Now, when you're given the name, always start with the backbone, and then number the backbone, and then put all the branches on it. So here, the backbone is what comes after the last YL, or if you have halogens after the last O, or YL. Remember the halogens, like fluorine, chlorine, bromine, and or iodine, when they're branches, you take the first syllable and just add an O. So fluoro, chloro, bromo, iodo. Those are branches. So after the last branch, either the last YL or the last O, in the case of halogens, you get your backbone. And here that's 2-pentyne. Now the prefix pent is telling us that we have 5 carbons. So let's draw that. Now we're used to doing zigzags, so we can start with zigzags. We're just going to have to adjust that because triple bonds, alkynes, are linear. So we don't want to keep the zigzag after we draw it in. But I'm going to draw it in just as a first step, as a rough draft. So pent, 1, oops, let me do this, 1, 2, 3, 4, 5. Okay, now I look at the infix, it's YN, and here it says it starts at 2. So I have to number this carbon chain. I'm going to do 1, 2, 3, 4, 5. Because the infix is YN, and there's a 2 in front, that means the triple bond starts at carbon number 2 and goes to carbon number 3. Now, as drawn, this is incorrect because it zigzags. These triple bonds have to be linear. I'm going to correct that in a second. Actually, let me correct it now, just so it doesn't seem confusing and it doesn't set in. So you wouldn't draw this. You would redraw this linear. So you would take this, between carbons 2 and 3, you'd have the triple bond. We know we are going to have carbon number 1 in the end, and carbon number 4. Notice how they're linear. And then we just have one more. And this one can zigzag because it's not involved in the triple bond in any way. So that it could go, I'm putting it up, you could have it go down, it doesn't matter. So that's 5. Great. And so those are really the same molecules. You have a triple bond between 2 and 3, you have 5 carbons total. Okay, so I'm going to get rid of this top one, which is technically incorrect because it misrepresents the shape of the molecule. So that's 2-pentyne, what we have there. So that's our backbone. In addition to that, we have a couple branches. It's 4,4-dimethyl. Now 4,4, that means we have 2 branches coming off of carbon number 4. They're both the same type of branch. That's why they're being smushed together and being given this prefix. And the type of branch is a methyl branch. That means they just have 1 carbon. So here's 1 methyl branch on carbon number 4 and a second one on carbon number 4. So overall, the structure that you get for 4,4-dimethyl 2-pentyne is this beautiful work of art right here. Okay, let's try just one more. You always want to start by drawing the backbone in these. And the backbone is what you have after the last YL or O if you have a halogen. So here you have ethyl, there's a YL. Let's see if we have another one afterwards. We do, we have one right there. And that's the last YL that we have there. So after that, what's to the left of that, that is our backbone, 3-heptyne. Now the prefix hept means we have 7 carbons. I'm going to draw this first. I'm used to thinking in zigzags, or you may be used to thinking in zigzags. So let's draw it with zigzags and we'll just correct it to make the molecule linear when we're done. So 3-heptyne, 1, 2, 3, 4, 5, 6, 7. Now we want to number that. So 1, 2, 3, 4, 5, 6, 7. The numbering it is also useful because it makes sure that you didn't add or leave out any carbons of the backbone. So hept 7. Now the infix for this is YN. That means we have a triple bond where it starts on carbon number 3, the number that's immediately in front of the name for the backbone. So from 3 to 4, it always goes to the next one, you have a triple bond. Now this is technically not correct because triple bonds are linear, and this is representing this as some sort of a zigzag. Now, this is not in a straight line here. So we have to redraw this. Let's start with carbons 3 and 4. And then we know that it has to be linear going to the next one, so 2 and 5. And from there we can just zigzag. So we still need 1, and then here, 5, 6, 7. And you could have had the zigzag in any direction. I just did it that way. Oops. So that fills in the rest of the molecule. You can see that that's really the same thing. This is correct though, and this is not on top. It's just a rough draft that we use to get to the answer a little bit more methodically and clearly. Okay, so this is our molecule. That's 3-heptine. So far we have our backbone. Now let's add the branches on. Our first branch is going to come off of carbon number 5, and it will be an ethyl branch. So off of carbon number 5, an ethyl branch. Eth means you have 2 carbons, so here you'll add 1, 2 carbons. There's an ethyl group. 1, 2 carbons. Then we have 2,5-dimethyl. Now, 2 and 5, that's where the branches are coming off. And then we have 2 types of the same branch. That's why we have this prefix di. The branch itself is a methyl branch. Meth is the prefix for 1 carbon. So you'll only have 1 carbon in these branches. A 1-carbon branch will be at carbon number 2, and a 1-carbon branch will be at carbon number 5. So this is a methyl branch, this is a methyl branch. They're on 2 and 5, so 2,5-dimethyl. And now that we've put all these pieces together, our final product is this beautiful masterpiece that you can frame and put on your nightstand. Right there. That is 5-ethyl 2,5-dimethyl 3-heptine. So in general, when you're going from the name to the structure, always start with the backbone. The tricky thing with alkynes is to number them and to redraw them as linear molecules around the alkyne, and then just fill in the branches. And also watch out for chiral centers, which could always appear. And we've done some exercise with those in previous chapters.